So let's have Kirchhoff's law or analysis of a circuit using Kirchhoff's laws, and then we'll be able to determine the use of Kirchhoff's law when we notice there are two or more batteries. Could also be three. Okay. Now there are two laws based off Kirchhoff's principles. We have the current law, wherein whatever current, so at a certain node or junction, whatever current comes in is equal to that comes out, that node or junction. Then we have voltage law. So we have a certain loop that we assign in the circuit, and then the summation, the voltages causing a rise, should be equal to the summation of the voltages causing a drop. In other words, the summation of voltages will be equal to 0. Okay. Suppose we have this circuit. We have two batteries, each with internal resistance. So what we'll be doing here is to treat these internal resistance so we can add them with a nearby resistor. And we have to assign first a common node where current from flowing from all of these components will pass through. And we can actually assign node A for that. So at node A, so we need to determine the current passing through each resistor. So the entering current is I3 based on the circuit given. This is equal to I1 plus I2. This is our first equation. Next will be, so this time let's try to simplify or try to pick an area or region from the circuit where we only have one battery, so that we can have a voltage summation easier. And one would be, so one perspective, we can take this upper region first. We're in the loop, so assume we'll go with the current 3. It doesn't really matter. So we go from positive to negative. So we have this loop. Okay, now KVL at this loop. So KVL at upper loop, this will be, so summation, so the one causing a rise, voltage rise, is said to be, so our battery, equal to those components causing a voltage drop. It's actually resistor, this resistor. So this is I3, meaning to say the sum of 40 ohms and 41 is R3. So we have R3 equals 41 ohms. And then needless to say, we have R1, 30 ohms. And then below, so internal resistance and resistor. So let's assign 21 ohms to R2. Okay. Now this is voltage drop across resistor 1 and voltage drop across resistor 3. Now we're looking for current, so we have to express these two in terms of current. So we can use Ohm's law. So battery equals I1R1 plus I3R3. We know the resistance values for R1 and R3 as well as the battery. So this is 45 equals R1 is 30. So 30I plus 41I3. This is our next equation. Okay, this is equation 1. This is equation 2. Next, we can choose another loop where we only have one battery. If we choose the lower loop or lower region, we'll have to deal with two batteries. It's still alright, but let's try to simplify first. Find a simpler one first. Let's assume the loop is counterclockwise this time. So we have here, we'll be only considering the sides. Okay, we're considering R2 and R1 only. We're trying to ignore the middle section. So KVL at big loop. So we have what will be causing a voltage rise here. So we can assume that whatever is going with the flow, so going against the flow would be, so we have R1. And apparently, so our battery here causes a voltage drop. Okay, because so we are trying to go with the flow of the current, but then here, so the flow of current is that way, and it counters with this current here. So we have here I2 R2. So I just let me just write it again. V2 equals battery 1 plus voltage across R1. I2 R2 equals E1 plus I1 R1. Substitute known values. We have 21 I2 equals 80, and then we have 30 I1. This is equation 3. 3 unknowns, 3 equations. So express this. What's common is I1. So express this in terms of I1. So I3 is equal to 45 minus 30 I1 over 41. I2 is equal to 80 plus 30 I1 over 21. Plug into our first equation to get I1. So do the algebra, or you may immediately use your calculator since you're allowed to use. And after plugging in, we should get a value of around, so we have to consider here the convention, because remember that we're dealing with direction. So if we were to plug this in the calculator, this will give us a current passing through resistor 1. So we have a negative 0.8581 amperes, meaning to say that this direction, this assumed direction by the author, is supposed to be opposite. Anyway, we have our value for I1. Now to get the values for I3 and I2, we simply include the negative sign. So therefore I3, okay, I3 is equal to, so plug in, we have 45 minus 30 times negative 0.8581 over 41. This is still in amperes. And by plugging in the same convention, sign convention is negative, we will get 1.73 amperes. And lastly, for I2, so we can just use this. So I3 minus I1. So this is equal to 2.5881 amperes. Okay? So based on our initial, so using upper and big loop, I1 is, so we have 0. 0.8581 amperes. I2 is 2.5881 amperes. And I3 is equal to 1.73 amperes. Let's try to compare if we were to have a different loop. Okay? So let me print screen this. Okay. Now let me erase first. Suppose we will assign a different loop and see the difference of the difference in values. If we use the big loop, now let's have the upper loop as is. We'll only be concerned of the second loop. Okay. Second loop. Okay. Suppose we're assigning second loop at the lower. So how do we perform a KVL analysis at lower loop? Okay. So we have here a direction. What we'll do, we'll have this direction. Suppose we have this direction there. Okay. Now if that is our direction, then the one causing voltage rise equals voltage drop. Okay. So we have here, we have to consider summation of our battery sources. So KVL at lower loop, that will be 80 plus 45 volts equals, we have resistor 2 and resistor 3. And then this is 125, I2R2, I3R3. So this will be 125. We have resistor 2 is 21 I2. We have 41 I3. Now what's common between the three equations would be I3. So here we have to express this I1 in terms of I3. We have 45 minus 41 I3 over 30, and this will be 125 minus 21 I2 over 41. And then do the algebra we have here. I3 equals, we have I1 plus I2. Then we can get value of I3. So plugging in our calculators to get the value of I3, where I3 is our unknown value. So we'll have here, so if this is our sorry, this is baliktad, sorry. This should be 41 over 21. 41 over 21. So, because it's here. So this is 41, 21. So getting so we have a value of 1.73, which is the same as our answer earlier here. And after plugging in, we should get about the same values. So regardless if you have upper loop, lower loop, upper and lower, upper and big loop, you should get about the same values for current for this example.